Binary operations, inverse property. Consider a known empty set S which is closed under a binary operation star. If X is a member of the set S and we can find an element X prime or X complement member of the set S such that X operation X complement is equal to X complement operation X equal to E, where E is the identity element in S under star, then X complement is called the inverse of X in S. It is quite usual to denote the inverse of X as X raised to the power minus 1. X raised to minus 1 is not necessarily 1 over X, like the case would have been if this was an index. If we are expressing this in indices, then X raised to minus 1 would have been 1 over X, but for inverse property, this is just a symbol, so it's not necessarily 1 over X. You don't have to simplify it to become 1 over X unless the operation star is multiplication. So it is essential to note that while we can talk of the identity element for a set closed under star, we can only talk of the inverse element X raised to the power minus 1 of an element X in lieu of the set S. This inverse element, if it exists, is always unique. Note, an inverse is a number added to or multiplied by another number to give 0 and 1 respectively, e.g. 2 plus minus 2 will give you 0, and 2 times 1 over 2 is equal to 1. So minus 2 is the inverse for addition, and 1 over 2 is the inverse for multiplication. So the rule is that an inverse is a number added to or multiplied by another number to give 0. For addition, it should give 0. For multiplication, it should give 1. So if 2 is positive, the inverse will be negative. So such that when you add them together, 2 plus 2 minus 2 is 0. And for multiplication, 2 times 1 over 2, you get 1. So the inverse of 2 is 1 over 2. The inverse of 2 is minus 2. So the inverse of minus 2 would be 2. And the inverse of 1 over 2 would be 2. The inverse of 1 over 2 would be 2. Yeah. So note that operation A inverse is equal to E. Hence, whenever you are to find the inverse element, you must know the identity element first. Another thing you should notice is that if from a given operation A operation B equals to 2A plus 3B, assuming that's the operation, the rule of combination, and you're asked to look for the inverse of A, inverse of the element A, what you should do is that inverse is usually represented as A minus 1. So you're going to substitute the second element here with A raised to minus 1. So it will turn to become A operation A minus 1. So in this part of the equation, this B is 3B. So in place of B, you put A raised to minus 1. So that this is equal to A plus 3A minus 1. So take note of that. Let's take examples that usually is under inverse property. The operation star on the set R of real numbers is defined by A star B. A star B is equal to A plus B. So for all A, B members of R, find the inverse of A. Remember that the inverse of A would be A raised to minus 1. But before we can get the inverse of A, we need to get the identity elements, because from our relation, we know that A operation A inverse equal to E. So we need to know our identity elements. So let's so say first determine identity element. Determine identity element. So let the identity element be E. To do that, we are going to substitute E for B. So A star A star E is equal to A plus E, but A star E must be equal to E, so we'll put this in place of A star E. So A is equal to E plus E, and E is equal to A minus E. E is equal to 0. So next is let the inverse of A element be E raised to minus 1. So from this operation, since we are going to look for the inverse of A, we substitute B with A inverse, which is A minus 1, that will be equal to E. So but E is equal to 0. So A operation A inverse is equal to 0. Then we know that A operation A inverse but E operation A inverse equals to, from this general rule, that will give us E plus E inverse. So we put this in place of E operation A inverse in this equation. So okay, let's just put it this way. So one, so in 1 we'll put this in place of A star A1. So A, no need for this. So A plus E1, so that A raised to minus 1 is equal to 0. So here A raised to minus 1 is equal to 0 minus A, and E raised to minus 1 is equal to minus A. So A inverse is equal to minus A. That's the multiplication. The operation O on the set R complement of real numbers excluding 0 is defined by P operation Q. P operation Q is equal to PQ. So find the inverse of X. Now, before we can get the inverse of X, we say first determine identity element. First determine the identity element E. P operation E is equal to P E. P operation E is equal to P, but P operation E is equal to P. So this will give us P equal to P E, and E is equal to P over P, which is equal to 1. So next determine A inverse, determine A inverse. So determine A inverse, it means that this P would be A and this Q would be A inverse. So that would give us A operation A inverse. Oh, sorry, inverse of X. So it's not A inverse, X inverse. We didn't have X in the operation, so since we're looking for the inverse of X, it's the inverse of the element X. So we're going to replace P here by X and Q by X inverse. So determine X inverse. What we have here, what was given to us is POQ. So meaning that X inverse means the inverse of X elements in this set R prime. So to do that, we're going to replace P with X and then Q with this inverse, and that will give us X operation X inverse. And the rule of inverse part is that such operation must be equal to identity E, where but we're going to say but E is equal to 1. Identity is 1. So X operation X inverse is equal to 1. But remember that this operation X inverse was taken from this operation. So this operation is equal to PQ. So we're going to say, sorry, this operation is PQ, meaning that PQ X inverse that's equal to 1. So X minus 1. So where X is P and X inverse is Q, because it was taken from here, that's what it implies. So now X inverse equal to 1 over X when you divide both sides by X, so that X inverse would be the subject of the formula. So this is the inverse of X, the inverse of X. Okay, so that's the inverse of X. Number 2. Find the inverse of a real number y under the operation A star B. So A star B is equal to 4AB. To get the inverse, we need to first of all determine the identity element. First, determine the identity element. Identity element, and that is E. To do that, to substitute the second element with E, A operation E, 4E, E. And then we'll say but A operation E should be A. So A is equal to 4A E. And then E is equal to E over 4E. A1 that's equal to 1 over 4. So our identity element is 1 over 4. Next, determine the inverse of elements of Y elements. Now the question says we should determine find the inverse of a real number Y, whereas in the operation we only have A star B. There's no Y. So what do we do? This Y will replace A, then B will be replaced by the inverse of Y. So that will give us Y operation Y minus 1 equals to E, which is our identity element. But from this operation, because we replace A star B with Y operation Y star Y minus 1, where we have Y is A and Y inverse is B. So this will give us, from this operation it's giving us 4AB. So this will give us Y is 4Y minus 4Y reciprocal minus 1, and then E is what, 1 over 4. So what do we do? We're going to so divide both sides by 4Y. So Y inverse is equal to 1 over 4 divided by 1 over 4Y. So this will give us Y inverse equal to 1 over 4 times 4Y over 1, which is equal to 4 and Y times 1 is Y divided by 1 is Y. That's equal to Y. So therefore Y inverse is equal to Y. That's the answer. An operation star on the set R of real numbers is defined by A star B. A star B is equal to 2A plus 3, 2B minus 3 plus 2. Find the inverse of X. To get the inverse of X means that we need to replace A with X and B by X inverse. But before we do that, we need to get the identity elements of this operation. So first, determine identity element E. And then to do that, replace B with E. So it's now A operation E. So our B will be E. This part of the equation. That will be 2A plus 2E minus 3 over 2. But E operation E, the rule of identity property, or what identity property means is that A operation E will give us E. So that means E operation E is equal to E. So A is equal to 2A plus 2E minus 3 over 2. So we make it to the over 1 and then we cross multiply. So 2E is equal to 2E plus 2E minus 3. 2E minus 2E equal to 2E minus 3. So 0 is equal to 2E minus 3. This 2E will give us 3. So E is equal to 3 over 2. So identity element is 3 over 2. Next determine the inverse. And determine the inverse of X. And the inverse of X means that this A will be replaced by X and B will be replaced by X, which is the inverse of X. And it will be replaced, B will be replaced by inverse of X. If here is X and we are going to look for the inverse, then B would be the inverse of X. So that would be X star X so 1. And that's equal to E. Remember, okay, so first of all, it's equal to this equation 2x, so A is now X, 2x plus 2x inverse minus 3 over 2. But this particular part got meaning that X operation X inverse equal to E. So we're going to have that E 2x so X operation X inverse is equal to 2x plus 2x inverse 2x inverse minus 3 over 2 equal to 3 E, which is against the element, is 3 over 2. 3 over 2. So now we can cross multiply. So this will give us 2. So let's say cross multiply. So when you cross multiply, this will give us 2x plus 2x inverse minus 3 plus 3 bracket 2. 2 times 2x is 4x. 2 times 2x, 4x inverse. 2 times minus 2 is minus 6. 2 times 2 is 6. So it's 4x plus 4x inverse equals to 6 plus 6. And on this side, we can factor 4 out. X plus x inverse is equal to 12. So divide both sides by 4. This becomes x plus x inverse equal to 3. And we are looking for x inverse, so x inverse equal to 3 minus x. So therefore, the inverse of x is 3 minus x. 3 minus x. That's the answer. The binary operation star on a set of R of all real numbers is defined as A star E. A star B is equal to 2A plus 3B minus 5. Find inverse element in X. So first, determine the density element. And the density element, and that is E. So A star E is equal to 2E plus 2E minus 5. And that will give us so but A star E is equal to E. So we say E is equal to 2E plus 2E minus 5. So E minus 2E is equal to 2E minus 5 minus E. Relation to this side comes plus 5 is equal to 2E. So 2E is equal to 5 minus E. And then E is equal to 5 minus E over 2. So against the element is 5 minus E over 3. Next, determine the inverse element in star. Determine the inverse element. So I'm going to look for the inverse of E. Determine the inverse element. The inverse element of E. So now, if that be the case, E would, in this operation, B will be replaced by E inverse, which is A raised to minus 1, which is E inverse, which is A minus 1. So A minus 1 replace B here, so this will give us E star E inverse, will give us 2E plus 3E inverse minus 5, but E star E inverse equal to E. So E is equal to 2A plus 2E inverse minus 5, where E is equal to 5 minus E over 3, where E represents elements. So 2E plus 2E minus 5 is equal to 5 minus E over 2, so make it over 1, and then cross multiply, so 3, 2E plus 2E inverse minus 5 is equal to 1, and 5 minus E. So 3 times 2E equals 6E, 2 times 5 is 9E minus 1 minus 15, 5 minus E. So this will give us 9 E inverse equal to 5 minus E. This will move to the side, give us minus 6E. This will move to the side, give us plus 15. So 9E inverse equal to 5 plus 15, 20, minus A minus 6E minus 7E. So E inverse divided by sides by 9 equals 20 minus 7E over 9. Therefore, the inverse element is 20 minus 7E over 9. The operation star is defined over the set R of real numbers by x star y is equal to 2xy plus 3x plus 3x minus 6y. Find E, the inverse of the operation. So E, first find the identity element. Let's find the identity element E. So to get that, we say x operation E 2x plus 3x minus 6e, but x operation E is equal to x. So x is equal to 2xe plus 3x minus 6e. So x minus 3x is equal to 2xe minus 6e minus 2x is equal to factor E out, you know 2x minus 6. 2x minus 6. So E is equal to minus 2x over 2x minus 6. So E is equal to 2 minus x. 2 minus x over 2x minus 3. So 3 E is equal to minus x over x minus 2. So our identity element is minus x over x minus 2. Next, determine the identity, determine the inverse element, determine the inverse of the operation, determine the inverse of the operation. So we're going to use determine the inverse of x. So if that be the case, we'll only replace y by x raised to minus 1. So this will give us x operation x raised to minus 1 equal to 2x operation x raised to minus 1 plus 2 x minus 6 x raised to minus 1. We say what x operation x raised to minus 1 is equal to E. where e is minus x. Okay, so where e is equal to minus x over x minus 3. So minus x over x minus 3 is equal to 2x raised to minus 1 plus 3x minus 6x raised to minus 1. So we bring this to this side. Minus x over x minus 3 minus 3x is equal to 2x raised to minus 1 minus 6x raised to minus 1. So on this part, we're going to simplify here. So we are seeing is x raised to minus 3, x plus minus 3 is minus x minus, and here will give us 3x x minus 3. So when we open our bracket, we have 3x times x gives us 3x squared. 3x times 3 will give us plus 9x over x minus 3. So we'll collect like terms. Minus x plus 9x will give us 8x minus 3x squared over x minus 3. So let's put this here. So that will be 8x minus 3x squared over x minus 3 equals to. So let's factor the inverse out. 2x minus 6. So now I'm going to divide both sides by 2x minus 6. So x inverse equals to 8x minus 3x squared over x minus 3 divided by 1 over 2x minus 6. So divided by 2x divided by 2x minus 6 over 1. So that's equal to 8x minus 3x squared over x minus 3 times 1 over 2x minus 6, which gives us 8x minus 2x squared over x minus 3 and 2x minus 6 is the answer. Minus 6. So this is our final answer. So 8x minus 3x squared over x minus 3, 2x minus 6 is our final answer. That's the inverse. So the B part says on line operation 11. Line operation 11 from x operation y, we know that from x operation y, we know that is 2xy plus 3x minus 6y minus 3x minus 6y. We'll go by this expression. X is 9, y is 11. So okay, so we say x operation into 9 operation 11 is equal to 2 times 9 11 plus 3 9 minus 6 11. That will give us 2. 9 times 11 will give us 99. And 9 times 2, 99 times 2 times 2, 18. 18 plus 1, 198. 198 plus 3 times 9, 27, minus 6 times 11, 66. So 198 plus 27, 198 plus 27, 8 plus 7, 15, 9 plus 2, 11 plus 1, 12, 2, 2, 5, 2 to 5 minus 66, 5 minus 6, count 15 minus 6, 9, 11 minus 6, that's 11 minus 6, that's 5, 159, 159, the final answer. The binary operation star with identity element 0 is defined on the set R of real numbers by n star n. equal to n plus n plus 2n. N and n are members of R. For what value of m does the operation have no inverse? Solution. For we to get the value of m from which the operation would not have inverse, first of all, we must get to find the inverse of n. So first determine the inverse of n. So in that case, since we're looking for the inverse of n, we're going to substitute this n with n inverse. So n operation n inverse is equal to e from inverse property, where n operation n inverse equals to n. So n plus n will be n inverse plus 2n n inverse equals to e. And we're told that e is 0, the identity element is 0. So where e is equal to 0, so n plus n inverse plus 2n n inverse equal to 0. So this will come to this side. N inverse plus 2n n inverse equal to 0 minus n. So n inverse plus 2n n inverse equals to minus n. So we factor n inverse out. 1 plus 2n is equal to n inverse. So divide through by n inverse. N inverse is equal to minus n over 1 plus 2n. So these are inverse. Now the question says, for what value of n does the operation have no inverse? For the operation should have no inverse. It means the inverse must be undefined. Means the inverse. It means n. It means the value of. It means m must have a value that would make the inverse to be I would make the inverse to be undefined. So when we see m must have a value that will make the inverse, this is the inverse minus n over 1 plus 2n to be undefined, means that the denominator must be equal to 0. That is the denominator must equal to 0. So 1 plus 2n is equal to 0, and then 2n is equal to minus 1. So n equals to minus 1 over 2. So if you put this in place of n here, and you solve and simplify, discover that this denominator will be 0, no matter what the value of n here is. So let's say n here is minus 1 over 2. Minus 1 over 2. Minus times minus 1 over 2 is plus 1 over 2. So 1 over 2 divided by 0. That will give you a function that is undefined. So once it's undefined, means that n inverse does not have any value. So that's what it implies. So for what value of n does the operation have no inverse? This is what the value of n has to be for this operation, inverse operation, not to have inverse. So these are final answers.